You also have this problem, right? Things work on dev environment, but that thing doesn't work on a QA environment. Things work on a dev and a QA environment, but that doesn't work on a production environment. This is really nightmare for every developer. Let's solve that problem. Docker is there for you. Hello, I'm Krish. Most of you already know me because I did the microservice video course. If you think that is completed, that is end, no, it is not end, but we need to know about the Dockers to deploy the microservice as well. But I'm going to create this Docker video separate as a separate video, because if anyone does not interested about a microservice but interested in Docker, they can use this video. Okay, let's continue video. Okay, so in this video, I'm going to cover everything what you need to understand to get into Docker, right? So let's start. First thing is, why containers? If you consider like 10 years back, when you're implementing a new system, we used to get physical server for everything, right? So I explained this in the previous video, one of the previous videos, so I'm not going to go very detailed, but let me to touch that. So 10 years back, if you are going to implement a system, we may need a server, physical server for everything, like for database, for application, for a web server, for everything we need a new server. So taking this new server and install everything and deploy, it takes months, and more than that, we need to hire specific people to maintain this. So next generation was virtualization. So that means, like for example, we get a big server, we install something like a vSphere or some virtualization platform onto that, and on top of that we create new machines, virtual machines. Those are not real machines, but those are virtual. It was quite popular, but we still keep one problem, because still those machine, those VM has an operating system, which means we need to install the operating system, we need to license it, we need to install the patches, security, and everything we need to continue. So we solve one problem being a physical server, but still we are continuing that. So then the kind of a 2.5 generation, we moved this everything into cloud, right? So ever since that, we don't have a physical data center on premises, but we have the same structure but on a cloud. So in 2013, around 2013, when this microservice concept came out, right, there was a concept called one service per host. If you're implementing a microservice, you need to implement one service per host. And also, people were talking about how you can avoid the problem of this virtualization, right? And so the big resources and everything, how you can avoid this. And people were thinking, in order to actually run a service, you just need a few features of operating system. Mainly it's a kernel. So why we need to take everything install into everything into a box and like put huge memories on top of that just to execute a service. So that is where container was born, right? So if you go here, you can see like we have a few point listed, right? So it's a faster bourne time. Like if your VM taking like a 5 minutes to bourne, but this can spawn out within like 10 seconds, maybe less, right? And it's very easy to maintain and everything. So you can see in this diagram, it's comparing what is the difference between virtualization and Docker or containerization. So virtualization side, you can see you have infrastructure, you have an operating system, right? So I'm sorry, in the containerization side, you have an infrastructure, operating system, Docker. Docker means kind of a Docker engine, right? For now, since you don't know, so you can create multiple Dockers on top of the Docker engine, right? So here, if you compare this with the virtualization, you have infrastructure, you have some VM platform, and then you have to have a guest operating system, right? So then on top of the guest operating system only you can deploy your service. So this is the difference. Here you have operating system for each virtual machine, but here you don't have something like that, right? So then people are thinking, so Dockers are inheriting operating system which is the underlying operating system. That is not exactly true, right? We can learn that how that works, but that's not exactly true. So then as a Docker, people confuse this. Docker is if you write with a simple D, Docker is a technology. But if you write something with a capital D, this is always true. It's a company. Docker Inc. is a company which contribute and which they build this and support this, and it's a company, right? So don't get confused with these two. It's like they became leaders in the marketing, and they came first, so people used to use their name. Other than that, it's just other company. But Docker with a simple D is a technology. So, and there's one other myth going with the Dockers. This is how it's work. Let's say you are running a Docker engine with a 32 core machine, right? So some people start to think then only 32 Dockers we can run on that server. Why? Because we know Docker need a processor, right? Docker is a computer need a processor. That is not exactly true, right? So a Docker, how the Docker works, we can see this in like in few minutes. But how the Docker works, it's like exactly other process, other application on your machine, right? So you have a host computer. If you go back here, you have a host computer, right? So on top of that, you install something called Docker engine. So this is the main app, right? So this is kind of application. And each Docker is kind of a separate process for the operating system, main operating system, right? So therefore, there is no such limitation like that. So Docker 1.12, now like we have a very latest versions, but Docker 1.12 is kind of the milestone version. Why? Because we had a Docker separately and socket plane separately, right? So in a 1.12 we put together, and also we inbuilt Swarm into that, right? So before that we used to use a Kubernetes mainly, but still you can use it, right? It's not tightly coupled and sealed it, but you can use a Kubernetes. But if you don't need like fancy features, you can stick to Docker Swarm. That's something for other video. Okay, so this is how Docker you can see Docker today, right? So any operating system basically support for Docker, but that's in theory. Basically the Linux is the operating system which support for Docker. That being said, I'm not trying to tell Windows or Mac or any other operating system doesn't support for the Docker. Here's the problem: if you're on a Linux, if you're in a Mac, it's really easy to install and work with the Docker. But if you're on Windows, still you can use it, but little bit painful compared to the Windows, the Mac and the Linux, right? So more than that, you can use the Dockers on the cloud, right? So these points we already discussed, right? Docker is just a tool, right? It's designed to make things easy. So why I'm just jumping through this? If you go back to my videos, you can see there are videos we detail talk about Docker, right? I don't want to repeat same thing, so that's why I keep running through this. So Docker is for whom and for anyone, right? So that's why I want to isolate this from the microservice videos, because anyone can use Dockers, right? It's not limited to microservices. It doesn't limited to even for software application, but even for infrastructure people, even for someone who's handling Apache kind of web servers, the containers, Jenkins, testing, QA, right? Especially QA, they can set up a testing environment with the Dockers. Anyone can use a Docker. Right, installation is very easy on a Linux and a Mac, but it's little bit hard to install on Windows, right? Because it expecting certain features, and you have to go and enable things on the BIOS and come back to services. I'm not familiar with much on that, so you may need to depend on a Google or ask from someone who have experience on that, right? So Docker, when you install the Docker into Mac or any other than the Linux, if you install anything, if you install Docker for any other operating system, so there was something called Docker toolbox, right? So Docker toolbox is kind of make a trick, because Docker need Linux to run. So what the Docker toolbox was doing, it installed a VM, virtual machine on your computer, and then Docker client talk to that virtual machine, and then virtual machine is the one who really process the Docker commands. I'll show a diagram in a few minutes, right? But now they came up with the Docker desktop. Its architecture a little bit different than the Docker toolbox. Okay. So this is the old version Docker toolbox. So this is how it's work, right? So you have a mainly your operating system, and then you have a some virtualization, right? It's installed usually VirtualBox, and on top of that it create the install the Docker. So when you give a command, it really talk to this VirtualBox, and then VirtualBox is the one who really process your Docker command, right? So that's why when you use in this Docker toolbox technique, so sometime it says the SSH not working, and the host is not responding, and so many various errors. The reason is that. So if you consider Docker Desktop, which is the latest edition, latest version of the, and kind of a successor to the Docker Toolbox, so that's mainly do a very different technique to get this done, right? So you can see here they have the Docker installation, and what they do is they kind of use symbolic links, S links, and to talk to the Docker installation on your Mac, right? Let's say you install the Docker Desktop, so that application has certain libraries, right? So they connect with the original, they kind of a like masquerade. I mean, it's not really masquerade, it's kind of a shadowing the original files, right? So and then it gives the real Docker behavior. It don't need any more the VMs anymore, virtualizations anymore, but not a native support, but kind of feel like a native support for Docker. Right. So how to install this, I am not going to cover here, because that's very easy you to do. You can follow Docker documentation or any YouTube videos or any other blogs or something, right? So what I am going to show you here, if you successfully install the Docker and give the Docker version command, so it will give you Docker build and what is the version you are installed, right? And also you can give Docker info, right? Oops, sorry. So Docker info command, so that tells you everything about your Docker installation. For example, how many containers are running, how many containers are forced, and how many containers are stopped, right? And how many images. Let me explain the difference between images and the containers, right? And it has bunch of information, IP address, and everything what you need about your Docker installation. Okay. I need to explain you something before we go anywhere, right? So that's a relationship between image and a container, right? So if you got the Docker info, you will see it's some section it says about the images, and some section it says about the container. Here's the relationship. When you pull something, right? Pull where? Let me to explain that in a minute, right? So if you pull a Docker that comes as an image, right? Then you can run the image. Running image we call container. Then you can stop the container. It come back to the image, right? So in other words, container is a running image. Image is a stop container. It's a little weird, right? So you see this diagram. So you can see if it is up and running, it's we call container, right? So you can give the stop command, and then it's stop, right? So then you can give the start command. So this is the image. This orange color thing is the image, right? So then you give a start command, and it become a green thing, which is a container, right? So if you go back our terminal again, right? So now let me do this very first command, right? So which is Docker images, right? So when you give this command, it tells you how many Docker images stored on your local machine. That means there has to be a remote, right? This is how it's work. Docker has a concept called Docker registry. Like you can build your Docker on your local machine, right? It's just an image, right? You cannot, I mean, once you build it, you cannot edit it. You can edit it, but generally you cannot edit it, right? So what you need to do is, if you're doing the right way, you need to refer that Docker, that image, and you can do your modification and create a whole new image, right? If you take really, the original image doesn't get edit. It doesn't get updated, it's image, right? So image is not supposed to update. So what you do is, you get that image, you do your own thing, your own configuration, and you create new image. Okay. So then you can store this image. Store where? That is the way we call Docker registry, right? So we have two parts. You have a local machine, wherever the environment you work on, and then you have something called Docker registry. So you can create your Docker and push into Docker registry. Docker Hub is one of the famous Docker registry, and then you can pull this from anywhere, right, and get it work. That is the where Docker is come handy. Let's say the biggest problem we are facing as a developers, sometimes things work on our machine, development environment, but when the QA people test it, it doesn't work, right? So and when performance team run the performance, that doesn't work, right? So to solve that problem is the Docker come into the picture, right? So you can create your own Docker, you push it to the Docker registry, and then you get that Docker and run on a separate environment, complete separate environment. But since Docker is an image, it carrying everything what you had on a dev environment, so you cannot have that complaint anymore. Okay, right. So now there are Docker images, right? So you can see here 1, 2, 3, 4. There are 4 images, right? So what I'm going to do is I'm going to execute my very first Docker with you, right? So Docker run hello world. So this is kind of a testing Docker to show test whether your environment is working or not. So observe what's happening here, right? Oops, I misspelled the command. Docker run hello world, right? So it says unable to find the Docker hello world latest locally, right? So then what it's going to do is it's going to talk to Docker registry. In this case, since I didn't configure any special registry, so my registry will be Docker Hub, right? So it's downloaded Docker hello world Docker from the Docker Hub, right? So you can see here pull complete. So that means it taken the Docker from the Docker registry, and it's the hello world latest one is downloaded, and then we start the Docker. So it says now it's working. So now see this, right? This is very important. So now if I give Docker images, you can see here, right? 1, 2, 3, 4, 5. Here only you have 4. So what happens is when you give the Docker run command, since we didn't have the Docker locally, right, it taken the Docker from the Docker registry and stored locally, right? So now we executed that. So now if you give Docker ps minus a, right, so you can see if you give the Docker just a ps, you won't see anything because this Docker is not running right now. What happens is Docker we executed the Docker, Docker ran and Docker exited, right? So now if you give Docker ps minus a, which mean all the states of Docker, like not only the running Dockers, running containers, everything. So you can see here hello world and created about minute ago, status exited about minute ago, right? That because we just ran that and we didn't try to keep it, right? So now you understand the flow, right? So if you don't, you can run the Dockers. If you don't have it, it go and check the Docker registry, it pull it, store your local, and it run from there, right? So now if you give Docker images, right, so you will see this hello world Docker, right? So there's image ID, right? So this is the one we can identify Docker uniquely. So now if I don't want this Docker image anymore, I can say Docker RMI, remove image, right? It says its name is conflict, right? So because it's already using, because you saw that when in the Docker ps minus a command, it is still running, right? It's just not really running, but it's still using. So what I can do is first we need to remove this container, right? So name is given as this. You can remove the containers by name, right? I always misspelling, right? So now it's removed. So now I can give the previous command, Docker RMI command. This time it worked, right? So now you can see Docker images. Now hello world Docker is gone, right? So now excuse me. So now we lead to one more step here. This is the full life cycle, right? So you can Docker pull, you can start, you can stop, you can RM. RM mean you remove the container, right? You pull, so now here you have an image. You start, now you have a container. You stop the container. You remove the container, you remove the image, right? So that is the full life cycle of the Docker. Okay. So now we can do something different also, right? Instead of we just using docker run, right? So if you get here docker images again, see what you have. So I am going to give new command docker pull Ubuntu, just Ubuntu, right? So now since we didn't specify the version, if you need to specify version, you after this docker name you can put a colon and give the version, right? Since I just gave a docker pull Ubuntu, what it does is it's pulling Ubuntu to my local machine from the docker registry. Okay, so meanwhile it download, right? Let's talk about a docker file. So now so far what we have seen is we just taken the docker someone is created. How you can create your own docker file? So one way is a docker compose, which is not going to cover in this video, right? But the basic easiest way to create a docker is a docker file. This is how it works. Docker file is just a file, it's arbitrary text file, right? You can write your specification to your expected docker. Okay, so now docker is just a machine, right? It's like a computer. So you need to have operating system, you need to have applications and everything, right? So how this is going to start? Let's say you want a docker with a Java installed, right? So now you think in a machine perspective, the computer perspective. To install the Java, you need operating system, right? So that means you have to have operating system. So you can get a base docker as a Ubuntu, or if you need any other operating system, you can take it, right? So now, since likewise we are pulling the Ubuntu docker, right? When you do that, it just pull Ubuntu docker into your local, right? So the docker file you can say from Ubuntu latest, or if you need the specific version, you can specify that. After that, you can tell now you need to install Java, right? Either you can have Java zip installation directory locally on your machine and copy into the docker, or you can ask docker to like apt get install Java 8 or whatever the usual Linux command. But you need to keep in mind, so Java changed their policies, and so now you cannot install the Java anymore with the apt command, right? You need to follow, you need to log into Java site, and that's a separate story, right? You can read the internet about that. But what I'm saying, if you need to install something, you can do that. So let's say to run your operating system, run your service, you need a specific directory, right? So let's say you need a directory called rencloud in the var logs, right? But a standard Ubuntu don't have that directory. So you need to create that. You can create a directory, you can write that command in the docker file, right? I'll show you how to do that. So you can write, okay, from Ubuntu, then install Java, your whatever the Java installation command, then mkdir var log rencloud, right? So then with this specification you are done. So now you have an idea about a docker, you put that into a file. Now what you need to do is you need to tell docker build this docker for me. So then what Docker engine will do is it get the base docker, whatever the Ubuntu, whatever the docker you specified, right? And create a directories, install Java, and do whatever you ask it to do to that docker. Okay, so let me show that in a while. Right, so now you can see it's complete its pull, right? So if you check the docker images now, so you will see Ubuntu image here, right? So now you can see this, right? So now I'm going to run this Ubuntu image. So what I'm going to do is docker run. Here I'm going to give two switches, one is a I, another one is a T. I means keep this std in open, right? Standard input open. T means, right, for interactive processors, right? So what does this mean? If you want to really get this TTY assigned to your Docker, you must give the I and T together, right? I mean, you can give minus and minus T, but mainly we give like a IT. What it mean, like now it will assign a TTY to your Docker, so you can get it run. Otherwise, what happens is we just Docker will Ubuntu will run, and there is nothing to do, it will die, right? So, and I can give my name if I want, right? Minus name is OS, and just run the Ubuntu Docker, right? So I can give D switch if you want, right? D mean detach mode. That means I will get the compiler here, right? So I miss one sign here. Okay. So now you can see it gave a hash to me and give me my terminal back. So that's what detach mode, right? Otherwise it will use the terminal itself, and when someone closes the terminal, your Docker will get killed. But detach mode mean it give my terminal back and it runs separately. So now if you give docker ps command, you can see the Docker is up and running, Ubuntu is up and running, right? So now what I am going to do is I am going to log into this Docker. So this is how you can do it: docker exec, right? I am still going to give the IT, right? And whatever the name I am going to log. So this is the Docker I am going to use, and run the bash on this Docker, right? So now I am inside that Docker. So if you check the host name, you will see now I am inside the Docker. So I am going to change my location to var log, right? So if I ls here, I don't have a directory called code labs, right? So I am going to create the directory again, mkdir code labs. If you ls now, you will see the code labs directory, right? So I am going to exit from the Docker now. So I am back on my laptop, my MacBook, right? So now what I am going to do is I am going to go inside the Docker again, right? The second time, right? I went to the Docker, inside the Docker, and I created a directory. I came back and I go in. So now again I am going to var log, right? And when I ls, you can see my directories is still exist, right? So I create a directory and I leave the Docker. I came back, but my directory is still there. That means I modified the image. Is that what really happened, right? But we said image is not be able to modify, right? We'll see what exactly happened. So I'm going to exit from here, right? And I'm going to stop this Ubuntu Docker stop OS, right? So now it becoming image back from the content is going to become image back, right? So OS again, right? So now I'm going to run this Docker again, okay? Run this again, and then I'm going to go inside this Docker again, okay? So now I'm going to go var log, and when I ls, I do not have the directory I created, okay? So that's what I said, you cannot really modify the image, right? So now what we experiencing is a container, right? It's not an image, it's a version of the image which is running image, right? So you can do any modification to that container, but when you kill the container, when you stop the container, unless you save your state, when you stop the container, it go back as an image. That original image did not affected with your modification. So how you can do something like this? Okay, so I'm going to exit from this, and I'm going to create a directory in my home called code labs, right? So I'm going to change the directory. Okay, so I'm going to create a file here called Docker file. Okay, so I'm going to update this Docker file saying, right, from, okay, from Ubuntu, right, from Ubuntu. Take the Ubuntu Docker and mkdir, right, so create new directory on a var, right, log called code labs sample, right? I'm not creating the same name because then you will get again confused, right? So that's it. I'm going to save this file, right? So now I'm going to give a command docker build -t. I have to give a name for this. I'm going to give code lab docker, right? And dot mean what is the Docker file to be used. If you want to use a Docker file from somewhere, you can give the path, otherwise this one, right? I'm going to execute this. Okay, I think I missed one letter here. Okay, docker build, right? So now it says error response from the daemon, docker parse error, unknown instruction, mkdir. Okay, so because mkdir is a command which runs on an operating system, right? So, but you need to tell Docker engine to run this command, okay? So, how you really should do this, right? I did that purposely to show you this. You can say run, right? Or there are multiple other ways. You just try with the run, okay? So, I am going to execute this command again, right? Now, you can see here from Ubuntu, right? It says that it used the directory and it's asking when I try to mkdir var logs code lab sample, it says no, I cannot do that, right? So, I did that error also purposely to show you something else. Why? Because in the var, you remember we went to the directory called log, not the logs, right? So, if you do something wrong in your Docker file, when you try to build the Docker, it kind of interactive, it tells you that you cannot do this, right? So, you don't have to worry about it, okay? So, this time I am not going to make any mistake. So, I'll build the Docker, right? So, let me to fix this. So, var log. There is other way you can do this. You can use a -p command, right? -p switch, then in that case Linux will create the directory from the parent, right? So, now I am going to run this. Obviously, this time it is going to create my Docker, okay, right. So, now if I check my Docker images, you will see my code lab image also there, right. So, you can see here, see the code lab image, right. So, now what the code lab image mean? Taken from the basic Docker. So, this is what it is, right. So, cat Docker file. So, what it is very simple. I have a basic Ubuntu Docker, that is a basic one, and then on top of that I create my own directory, right. So, that is what we expected to do, because we want to have a directory, but what happens is when you go to the Docker and when you create the directory, it does not have when you run the next time, right. But so, we create our own Docker, right. So, now let us do this. I am going to run this Docker. I am going to run this Docker just to make sure to not you to confuse. So, I am going to use the same command which I used to run the Ubuntu, right. Instead of that, here I am going to give code labs here, okay. So, otherwise it is everything same, but I am going to give different image, okay. So, I think my previous one is still running. So, Docker stop OS, Docker rmos, right. So, now I am going to run this again. So, now it is executed, right. So, this time I am going to log into this Docker exec -it, right. So, os bash, right. Why I am going to os? Because that is the name I gave. Now, I go into var log ls, here you go, you have your created directory. See the difference, right. So, we have taken the Ubuntu Docker, we ran it, right, then we logged into that, we create the directory, we leave the Docker and we stopped the Docker, then my directory was gone. So, the right way is you take the Docker and you create your own Docker on top of that, right. So, that is how the Docker world works. For example, if you need a Java Docker, you can take the Ubuntu and install the Java and you can save that Docker as a Java Docker. Let us say you need Java and PHP install or Java and Apache install. You can get the Ubuntu Docker, you can install the Java and you can install the PHP or the Apache and create your own Docker. But this is the right way. Let us say you have a Ubuntu Docker and you have a Java install, you have a Java Docker. The next time if you need Java plus PHP, you do not have to go from the Ubuntu. You can take the Java Docker and Java image and install the PHP on top of that, and you can install as a Java PHP image, right. So, when I tell this Docker and the image and everything, I am just used to tell that. So, you need to put the right word over there. If it is an image, it is an image. If it is a container, it is a container, right. So, I am going to do something production quality here, right. So, I am going to create a new file called index.html, right. Oops, okay, I am inside the Docker. So, I am going to stop this and remove it, right. So, I am going to create index.html here, right. So, here this is HTML file. I'm just give the basic one. Okay, so I just create a simple HTML file to say hello, right? So what I'm going to do is I'm going to go to my Docker file, right? Since I'm going to change the same files, right? Since we done this experiment, we don't need this anymore. From here, Ubuntu, instead of Ubuntu, I'm going to tell here HTTPD 2.4, right? HTTPD is the Docker version of the Apache server, right? You know, if you ever try to install Apache web server, so you need to download it and you need to run it and do some few configuration changes. You need to do so many things. They have a Docker which is the HTTP 2. I mean, you can use any version. The Docker name is HTTPD, right? So what I'm going to do is now I'm going to copy my index.html file which I created here. Since it's the same place, I can give the name, otherwise you need to give the path to this is the Docker location, usr local apache 2 htdocs, right? So that is the that's the location where we need to put our HTML files in this Docker. So you can find this information from the documentation, right? So I'm going to close this, make sure I didn't make any mistakes. Yeah. So now what I'm going to do is I'm going to build this Docker build -t code labs web, right? So this is a web page. I'm going to do the code lab webs and this one, right? So it says I don't have a HTTPD from my local, so it's going to pull HTTPD Docker, right, from the Docker hub, and then it's going to modify. I mean, if you just pull the HTTPD, it just has a like standard one. It doesn't have my web page. So what I'm going to do is use the same technique. I taken the base image and I modify it and I save as a separate Docker called code labs web, right? So we'll see how it works. Okay, so now I'm going to run this Docker, right? So I'm going to do is Docker run, right? I need to tell -p80, 80 port of my machine, redirect to 80 port of the Docker. Why I had to do that? Because Docker run on my machine, right? So when I send a request from browser, it go and hit my my MacBook IP. So for that, from there we need to redirect it to the Docker, right? So therefore we need to tell if anything come to my machine for port 80, redirect it to the port 80 of the Docker, right? So I can use the minus name called web and my Docker image is code lab web, right? So it says I think this because of port 80 already. I think I have some process run on port 80. So I'm going to run for port 91 but I'm going to send this port back to port 80 of the Docker. So now since I got an error last time, I think I have to remove my Docker. Yeah, that's a good practice to follow. Okay, so let's run again. So this time it's working, right? So this time it's working. So let's go back here, localhost port 91. Oops. Right, so now you can see it says hey, hello from code labs Docker, right? So ideally you should be able to run on port 80 if nothing on running on a port 80 on your machine, but since I have something run on a port 80, I just use a different port. Okay, so I'm going to, so now the problem with this mode, right, you can see here I don't have a terminal anymore, right, because terminal is occupied by my Docker process. So I'm going to use different terminal to stop this. Now if you go here, you can see it says shut down gracefully, because I send the stop command from here, and once I stop I need to remove it, right? So Docker remove web. Okay, so to avoid this problem, so if you go back here, port 91, now I don't have anything running here, right? So now what I can do is I can run the same command with the -d switch, right, with the -d switch. So now what happens is it run the Docker and it give my terminal back, right? So now if you go back to here, see this thing, it's working, right? So now you can see what are the running process docker ps. Now you can see it's run on a port 91 and it listening to port 80 of the docker. Okay, so these are very basic things, but you must know to start on the docker. I think now you know everything you need to get into docker, right? So if I summarize this, docker is a concept and the containerization technology, right? You can create a container from anything. You need to have a base container. You get that, let's say, operating system. You can get something Ubuntu or whatever the operating system image, and you can build your own docker. But what you need to understand is, when you run the docker, you can go into the docker and do any changes, like you can run to the docker and install the application or do anything, unless you save your docker state. When you come back and you stop the docker, your changes are not there anymore, because docker is mean we refer to container. When you stop it, it become an image again, right? So whatever changes you do to the image, it doesn't save. Okay, this is kind of an introductory video, right? So I'm going to do some advanced stuff with the docker as well. I did this mainly because this knowledge we need to continue our microservice course as well. Stay tuned, right? This is not the only Docker video we are going to do. We are going to do some advanced stuff, especially Docker network, Docker clusters and everything. So stay tuned. Subscribe if you're not subscribed yet, and also make sure you share this content on your social media so other people also can get access to that. Then see you in the next video. Till that, stay safe. Take care.